Hello, everyone. Thank you for coming. It's lovely to see so many of you, and I'm really worried that you've looked at the paper handout and seen that Ian Robinson was doing this talk and have come especially to see him, and you've got me. So I hope that isn't too disappointing for you all. My name's Sara Mitchell. I work for Amazon Web Services in London, focused on financial services clients. So I work as a solutions architect in the London team. So we're going to look at the AWS stack for analytics, starting with our kind of data architecture. And we want to just press the right button. I'm sure you've heard a lot of forces and trends, what different organizations see as the sort of data world as it stands today. And there are a few things that we see as important. I'm being waved at. A few things that we see as being important. Is it? Okay. I'm going to try and yell. I've got a really bad cold, so I'm hoping that doesn't then trigger a coughing fit. But okay, so looking at things like dark data, we care a lot about the fact that it would be really good for you to be able to store all of your data without having to discard things. So that's something key that we see as something important going forward for your architecture. The other thing that we're seeing, obviously, is just increasing amount of desire to use machine learning and artificial intelligence across those data sets that you're holding. And so the ability to have that data storage as the gravity and the sort of focus for your data architecture is really what AWS is thinking about. So where that data is stored, how you use it, and separating that out as part of your architectural strategy is what's key to our approach. So storage is job number one. And when we talk about storage in AWS, we always start with S3, Simple Storage Service. It's one of our oldest services. It's a highly durable service, 11 nines of durability. Highly scalable service. We talk about near infinite scalability. We can scale S3 as much as you need us to scale it. Object sizes up to 5 terabytes.
Would you be all right with a hand mic?
Yeah, that's fine, yeah. And it's really cost effective, so we can allow you to store vast quantities of your data in a really cost effective way and store all of your data. And they're going to get me a proper microphone now. I can't shout. I've got some water. Yeah, I'm good. Is that okay? Is that any better? Is that better? Better at the back? I'm not singing. I can't sing for this. This will be awful. Okay, 2 things to hold. So you've put your data in S3. You then want to start thinking about how you manage it. And it's not just dumb storage. It's not just put it there and leave it there. There's various capabilities around S3 that you can use to manage that data, reduce costs, and life cycle that data. So we can look at S3's various different qualities of service, both reduced redundancy and life cycling that data into Glacier, which is our cold storage data. And those new features came out of Glacier this year that allows you to put your data in Glacier, take advantage of the low cost that Glacier offers you. But then if you do need that data back quickly, you can pay a premium to pull it back quickly rather than waiting for the sort of usual turnaround time on data retrieval from Glacier. So that's a really interesting piece of function there. But then we look around some of the other areas that S3 gives you the capability to use. So content delivery around CloudFront and Elastic Transcoder. So the ability to deliver video content to users. If you think of some of our big customers like Netflix and the BBC, they're using those services with S3 as the background to that. Lambda as a sort of initial serverless functionality. Lambda then will tie into all sorts of dynamic programming models, event-driven programming models, focused on leaving your data in S3 and then processing it elsewhere. And then we're going to talk a little bit more about some of the analytics and database capabilities as we go forward with the talk. So I mentioned before, thinking about some of those lifecycle events of your data. You want to store all your data, but you don't necessarily need to access all your data all the time. So having the ability to implement some rules around when you move that data into cold storage and automating that process. If you're an auditable, for my customers in financial services, they have very strict regulatory requirements about keeping data for numbers of years. The ability to audit that quickly and easily, but also automate that process is really useful for them, and it saves them a lot of overhead and cost. So increasingly as well, the ability to catalogue your data, to know what data you've got and be able to query that catalogue really easily is becoming critical. The more data you store, the more of a job that becomes. So having the ability to discover what data exists in all of your data stores, search that data and build out a catalogue that you can then query in an easy way becomes important, and that becomes the sort of basis for giving you lineage and governance around that data. You can track changes, you can see who's accessed that data, and you can control who gets access to that data. So AWS Glue is a service that comes, it's a sort of 3 parts to a service, and we're going to talk the beginning of it at the data catalog level. So the data catalog part of Glue has crawlers that will scan the data sets that you give it. It'll scan the data sets, it will look for that metadata and build out a versionable catalog that you can then query over time. And you can integrate it with some of our other query services, so you can build out quite complex queries that give you the ability to scan across multiple data sets. You might have data in S3, you might have data in Redshift, you could have data all over the place, and you can integrate that all together with the data catalog from Glue. The other 2 components we'll talk about in a bit later, but both of those are around ETL jobs, so automating that transformation and running that as a batch process. We'll go into that as we go through the talk. So the Glue data catalog is a metadata catalog that's Hive compatible. It also will be supported by tools such as Spark and Presto and some others. It gives you some additional features. So we can search, as I say, we can search that data catalog, search the metadata, do some queries and analytics on that catalog. You can store connection into information about those data sources that you've scanned. You can classify files, you can tag them, and you can also version them, so you can keep a track of versions of the data as it goes forward and keep that kind of lineage of the data as you change it. So we build out the catalog using crawlers, and the crawlers will scan through the endpoints that you point them at. There are some standard classifiers that we put in with the product, so those will just come out of the box, as it were, and they'll scan and build out content. But you can also build your own classifiers. So if you have fairly unique content that you want to kind of document and catalog in a specific way, then that's an open platform that you can use. And then it will build structures either per file into separate schemas, or you can unify the schemas into one big schema and use it that way. Now, we talked about security being job number 1. At AWS, we talk about, storage is job number 1, but data is always job 0. And I'll probably get told off now. I said security is always job 0. So for us, securing that data is key. If your data isn't secure, then you're not going to want to put it in the platform. And we protect that, and we give you various tools in which you can secure that data on our platform. We talk a lot about a shared responsibility model when talking about security. And so the tools and the capabilities that we provide for you, we will put them in place. But it's always your responsibility to make sure you implement those in the way that satisfies your own protocols and requirements. And they're very, very flexible, so you can get highly granular role-based access control down to the object level in S3. We have various audit and monitoring tools. CloudTrail and CloudWatch will give you all of the API calls. You can know who has accessed what data, from what endpoint, what method call they've used. You can track that constantly on your platform. And we also provide a whole host of key management tools. So both managing the life cycle and the usage of those keys, or using hardware-based HSMs. So what's important is that the data is what we're securing. So we're controlling the security at the object level, at the data level. And then each of the tools that will interact with that data has to go through that security layer. So all of the tools around data storage all have to be managed and controlled by IAM. So IAM is our role-based access control service. And you build out users and roles and policies that give very specific permissions to individual users. So a user might be able to look at something, not change it, or might be able to add data to a data store. You can control it from source endpoints, user IDs, and all of that is tracked within CloudTrail as each API call goes through the system. So it's a highly granular service in that respect. So here's an example of a security policy for S3. So if you look here, this one has actually put a condition in there that controls the IP addresses that can actually access a particular piece of data. You can put bucket policies on the whole bucket. You can lock down certain objects. And you can also enforce encryption on your data. So we always recommend that people encrypt their data both in transit and at rest so that you have that multi-layered security approach to your data. S3 can allow you to version your data. So if some you put some data in that's incorrect, you can go back to earlier versions, and you can keep a history of versioned sets of data from S3. And finally, we can put multi-factor authentication onto the delete processes around your data, so that even with a user who's got permission to delete that data, they still have to go through those additional checks in order to actually remove data from the bucket. So I mentioned earlier encryption options for your data. So there's built-in encryption options with the service. So you can use server-side encryption. You'll not notice it happening. We manage the keys. We encrypt the data. We decrypt the data when you go to access that data. For a lot of organizations, they want something that they have a little bit more visibility and control over. They want to be able to either provide keys or understand and generate keys more regularly. So for that, we would recommend using the Key Management Service, KMS. That gives you the ability to have a lifecycle policy around your keys. It will automate refreshing those keys and keeping a catalog of the earlier versions of keys, so you can go back to older data. Or you can import your own key material from whatever sort of minting process that you have on-prem. Finally, we have the AWS Cloud HSM. So that is a dedicated hardware HSM module that lives inside your network in the AWS infrastructure. That has a complete tamper-proof system, so there's no way of repairing it. If you lose access to it, it's gone, and we have to give you a new one. So it's a highly tamper-proof system, and you can use that to generate keys for the platform if that's what you want to do. But for a lot of customers, they're going to continue to use an on-prem HSM, and that also is a very common scenario that we see with a lot of customers, and they will use that as the way to manage that key process into their AWS platform. So we've talked about the storage of the data. We've talked about how we protect and secure that data, how we manage access to that data. So let's look at how we're going to get that data in there. So we've built out our platform, and there's various ways of importing, ingesting data into Amazon, into S3. So one of the issues that customers do have with ingesting data is around the time it might take to transfer data, especially over large distances. And so Amazon has its own dedicated network, and so we can use transfer acceleration service to actually move your data rather than having it run across the public internet. So if you see this diagram here, someone I don't even know where that country is, that's really bad. Someone is wanting to transfer data from one side of the world to the other. And if over the public internet, that may or may not take some time. But actually, we can use our network of global points of presence to transfer your data onto our backbone, and then you can upload your data via our dedicated network that's not on the public internet. So that will give you much faster upload speeds if you're sort of traversing over large geographical distances. So what kind of services will you use in order to put your data into AWS, into S3? So we look a lot at streaming data now and having the ability to have that constant flow of data. So the Kinesis product, there's two elements. This slide looks at Kinesis Firehose, which is really a sort of point-to-point batch processing of inputting data. But we also have a product, Kinesis Streams, which if you're using Kafka, is essentially the equivalent to Kafka, but it's a managed service. So whereby if you're using Kafka, you've got to manage that infrastructure, manage the scaling of that infrastructure, make sure it's always available, doesn't break. If someone gets paged, someone's got to come and fix it. You've got to maintain and upgrade it. Whereas with Kinesis Streams, it's a managed service. So we manage the capacity, we manage the updates, and we make sure it's always available and is implemented so that it can constantly be streaming your data. When the data comes in, we can also sort of funnel it out into various different endpoints. So not only can you pipe that data into S3, but you can also push it into Redshift or Amazon Elasticsearch if that makes more sense for your use case. Now, another service, database migration service, is more concerned with migrating data from database to database. So it can do a full load of a database, and you can join those two endpoints together. The limitation is one of those databases has to be on AWS, but we don't mind whether it's off-prem to AWS or between two AWS data sources, so we can manage both endpoints. And we can also do a sort of streaming CDC type migration as well, so you can do that initial upload and then that continual update rather of the data as things change. So a couple of other services on the slide. If you look on the left-hand side, Snowball has been around for a little while, and it's not something people always know about. And it's a rugged device, so rather than relying on a network in order to upload your data, for some use cases, often where there's often large amounts of data, it makes more sense just to physically put it on a device that you then securely deliver to AWS. So you order a device, it gets delivered to your premises, you plug it into your network, and it manages upload of the data onto that device. It then gets couriered into AWS network, and we do the same. And you can set up a system where you have one delivered every week if you want to do that. In the US now, they've got trucks. So for customers that have exabytes of data, where it might take many months, years to load that data over the internet, there's now the ability for a truck to just pull up at your data center, and we'll take all your data and drive it to one of our data centers and plug it in. So the final part to the story is what you're going to do with all this data. So you've got the ability to store all of your data. You don't need to delete any data. You can just infinitely scale that capacity in S3. You can ingest all the new data in various ways, streaming it, sort of bulk upload. But then what you're going to do with it and how you're going to process it. And because you've got all your data in one central place, it gives you a lot of flexibility. You don't have to choose a technology beforehand. You can just leave the data in its raw format and pick and choose a technology to process that data depending on the use case that you're dealing with at that time. So if we look at this slide, we've got a few here. So I think the interesting things at the moment, and probably where we're looking most at, are around Hadoop-based clustering, so using our EMR service. So if you've got your data in S3, you can run dynamic clusters in EMR. So EMR is a Apache Hadoop-based infrastructure. but it's giving you the ability to keep your data separate. So your data then becomes very unique to each cluster. Every user will log on, create a cluster, run their job, and then that cluster tears down at the end of it. This gives you a few things, really. So it avoids the need to have these long-running clusters that live in a data center where you have to size and maintain and run that. You have to keep that patched and upgraded. You have to make sure it's always available and manage lifecycle events for that cluster. Each cluster is dynamically run. If you need to rerun a cluster, then that's a very quick process, and cluster will deploy in a few minutes. It also gives all of your jobs are running in an isolated fashion. So rather than multiple users all trying to share the same cluster, they dynamically deploy a cluster and use our compute resource for their job. And so they get the ability to have their own isolated environment in that respect. They're not sharing with a number of other users, and potentially, if your system is getting sort of heavily overloaded, then they would run out of capacity. We'll look a little bit more about some of these other services as we go through. But what I wanted then to pick up again on is the other parts of Glue. So Glue has an ETL capability, and it runs as a serverless ETL. So it will scan and build out Python-based transformations for your data. You can augment those and build those yourself, but it will build a standard format for you. It will then run as a managed ETL. So it runs as a serverless format. You can batch these jobs up and have them running automatically. And you don't have to care or think about provisioning any of the infrastructure that you need to run that. You just say when that job needs to run, and the AWS platform will manage deploying that compute resource and deploying that job and running those transformations. So you can have that running on a regular process, iterating round, running all the time. The third part of Kinesis, so we talked about Kinesis Streams and the Kinesis Firehose for the sort of batch upgrade, is Kinesis Analytics. So this gives you the ability to query, using SQL, the data that's coming into your platform over Kinesis. So you write SQL queries on that data and process that data in real time. You can then sort of pass the outputs of those data onto your Lambda functions. You can build out quite sophisticated reactive architectures based on the outputs to those streaming queries. And it works as a window, so you're building out just a sort of sliding window over your data as it flows through the pipe. And as you see, there's just an example of that SQL there that you can see. So then we have a couple of other services. So this one is Athena. Athena allows you to query that unstructured data that you've got in S3, but again using SQL. So you can build out standard SQL queries, but run them over just an unstructured data source in S3. And this is also really powerful if you want to start merging data. So you maybe have structured data and unstructured data in different places. You can use S3 across those RDS databases and your S3 data stores and start to build out different things without having to sort of move lots of data around or have data in different places. The other side of that is our Spectrum product. So that does a similar thing, but you're running that over our Redshift data warehouse. So again, you're using SQL queries across that across S3 and across your Redshift database. So combining that columnar data store with your unstructured S3 data and building out queries using SQL in that way. So Amazon QuickSight is a way to build quite graphically rich dashboards and graphing mechanisms. So if you're using Athena or anything else really, but Athena, you could pipe the outputs of those queries into some rich dashboards that would then give your business users a sort of a graphical visibility into that data. So they're not having to interact with the SQL and with the low-level code, but they're getting those interfaces into sort of various graphs. And we've got some examples of, just various ways that you can graph out that data, play around with the fields, dynamically change things, and build out different dashboards for your sort of business users to kind of work with that data in a graphical way. And then the final part of looking and working with data now is how we interact with both machine learning capabilities and analytics. So Amazon is building out various machine learning capabilities. We have Amazon Machine Learning, which is a highly abstracted way to pass data into machine learning modules, and it will run that data through some predefined modules that you can pick and build out a trained model at the end of it. You can then iterate quite quickly. So if one model isn't giving you the outputs and the results that you want, you just then pick another one and run the process again. So it's a really easy to access capability where you don't really have to understand how those machine learning modules work. You just have to pipe them through the system, and the system is built in such a way that that's very straightforward to use. You then end up with a trained model that you can then put in front of put behind an API rather, and then you can just pass new data into that model going forward and get the predictive analytics back out of that model. We have similar machine learning libraries on EMR, so on our Hadoop platform, that use Spark ML, and you can again build out quite rich machine learning capabilities from that EMR cluster, from those Hadoop clusters that you're running. Our AI services, there's 3 listed here, and again, this is an area where we're seeing a huge amount of interest. Lots of kind of very conversational interfaces. I'm sure many of you are aware or own an Echo, an Amazon Alexa Echo device. So Amazon Lex is essentially the natural language module that sits behind Alexa. So you can use Lex APIs to put that same capability into your applications and build out smart chatbots, conversational interfaces, perhaps using lambdas to kind of interact on your applications in a very natural way. We have another product called Amazon Connect, which is a call center product that uses the same technology. So you can have an automated call center that will have a fairly lifelike conversation with your customers, rather than a press 1 for sales, press 2 to complain. You can actually just say, what do you need today? And have that conversational interface, which is really dynamic. What's nice about it too is that you can dynamically change what the thing says. So you just log on and retype the intents, and you immediately have a different interface rather than a sort of re-record a voice, go through a sort of slow engineering practice. Polly does text-to-speech. She runs 47 voices, 24 languages. There's various different sort of accents. You can have a Welsh accent or an Australian accent in English and all sorts of other languages. And that gives the ability to really quickly have some text that's just translated into a voice on your application. And then recognition gives you image analysis. So you can pass it a picture and it will return a JSON document with a load of features with confidence levels about what those features are. So you can just pump in matching, find this face in this crowd, and it will scan that image and look for the face that you've passed it. You can pass it animals. You can play around with this, and it's all as an API. So that machine learning capability is sitting behind an API. So you can have a huge catalog of images sitting on S3, and use those images to do matching. We have police forces who are using it as a way to allow their police officers to walk around a city and get alerted when somebody that they're interested in walks past them. So there's some really interesting use cases that you can build with this. And finally, for the real data scientists in the room, we have the deep learning AMI, and that is a sort of click deploy machine image that comes pre-built with all of the sort of popular tools around machine learning. So it's really easy just to stand up a virtual machine pre-configured with all of the tools that you would want to use for machine learning and quickly get going, rather than having to have that running on your own machines, on your own hardware. We work with the chip providers to provide GPU accelerated instances for supporting high sort of density compute, and that's really easy to deploy. So this is my final slide. I hope I've kind of given you, it's a bit of a quick tour around our data stack. Key part of our architecture is S3. We've got many tools for ingesting data, many tools for processing it. I hope that's been helpful. Thank you.